Hi, and welcome to this third part of trying to complete the answer of buoyancy neutral object goes up with hydrodynamics plugin. So I would like to do this third part to show you how to do it with geometric shapes. So I already done an answer and given a video of how to do a simple geometric object, then how to do it with a complex geometric shape made with 3D meshes. And now I would like to show you very fast how to do it with geometric shapes, because we saw that if you do it with meshes, this plugin doesn't support really the whole mesh, so it only does the bounding boxes. So maybe you're more interested in using in the collisions, putting not meshes but geometric shapes. So I've used, as always, ROS Development Studio, and here you can see this is a geometric representation of the fish that you saw in the latest video, in the answer. So basically it's in the same places, it has the same joints, just as I've replaced the three-dimensional shapes by the collisions with geometric shapes, but also the visuals, so you can see which geometric shapes are used for each part, as you can see. So here, if we go to, let me close this all. So I've generated, inside here, I've generated a URDF, and inside it, it's a geometric version of the same one that we used in previous video with the three-dimensional shapes. So let's put it here to compare. There we go. So as you can see, for example, the base link, which is this red part, the big one, you can see that, for example, here, so base link, and then you see, in this case, well, in this case, no, wait a sec. No, sorry. Yeah. So here it's the base link, and here in the collisions and in the visuals, you have the same three-dimensional shape, which was the face of the fish. In this case, in the base link here, you can see that we have replaced it by a cylinder of these dimensions, which more or less correspond to the same dimensions of the three-dimensional shape. And that's it. So how do you do it? How do you do buoyancy with that? Well, you do it exactly the same, because you only have to put this plugin here with the fluid density. There you go. In the same way that you did it with this one. I've just changed it to 1000, so exactly the one of the water, because in geometric shapes, it works much better than with bounding boxes and so on. So you can adjust it precisely. So what's the procedure? So the procedure, I'll show you just one. So in this case, you have this base link, which has the mass that you stated. But to calculate it, I've generated a script that makes the work for us. And I'll link it in the description below and in the answer, of course. So I'll show you this script. There we go. So this script, what it does is calculates for spheres, cylinders, and boxes the mass that you need to have neutral buoyancy. How do we do that? Let's do an example. So for example, this one is a cylinder. So let's go to the cylinder and say, okay, calculate buoyancy for cylinder, which is this function here. There we go. And what we're doing is we're calculating the volume, also the area, just for fun. We don't need it. And what we do is we calculate the fluid equivalent mass would be the fluid density by the volume. This would be the mass of fluid that it displaces, this volume. Then we'll calculate the buoyancy generated by this chunk of water, let's say. And this is the mass by the gravity. And then we calculate the mass, the real mass, that it's the mass that we stated in the URDF multiplied by gravity. Once you have it, you can calculate the final weight force. So it's the difference between the buoyancy force, which is upwards, and then we have the weight, which is downwards. Once we have it, as you can see, it calculates, okay, if it's negative, then it will sink. Why? Because the weight is bigger. If the weight of, if the difference is 0, then it will have neutral buoyancy. And if the buoyancy force is bigger, then it will fall, it will float and go upwards. And basically this is what it does, this script. And we calculate the volume of the cylinder, if you want to see how it's calculated, but I mean, it's just a mathematical formula, which is pi by radius square by height, and that's it. So let me show you how we use this. There we go. So we have, for example, let's say we have the cylinder, and then we state the mass. It doesn't matter, so I can put 0.2. This is for calculations. So if you are interested in making a boat, then you would like to have positive buoyancy. So you can use it for this. Okay, then I'll go here and state the radius. Yep, there we go. And the height, which is the length here. And then the density, for example, if you are going to be in seawater, then the density won't be 1000. Okay, so depends on what you want and what the fluid. It's very useful for this. And it calculates everything. So you have the volume of the cylinder, of the geometric shape, and then it states here, mass of the fluid of cylinder, volume cylinder. This should be the mass of sphere for neutral buoyancy. There we go. Then it says, okay, weight force of the cylinder, blah, blah, blah. So resulting force is this one. So it will float. Does it make sense? Okay, it does, because we stated mass of 0.2, so it's lighter than it should be to have neutral buoyancy. So it will float. Perfect. So you have to do this with each one of the elements. So you have to do that with all the links. This is one step. The other step, which is once you have this mass, so you'll have to take always this mass and copy paste it there to have neutral buoyancy. Once you have it, you have to also adjust the inertias, because you are changing the mass, so you have to adjust the inertias. Okay. Also, if you didn't take into account the geometric shape, of course, you have to bear that in mind. For that, I have another script, which I link also below, which is the inertial calculator, which calculates the inertia matrix of geometric shapes, so boxes, spheres, and cylinders. I link it down below. It's a bit more complex, but basically what it does is calculate that. So that you just have to copy paste. Okay? So for that, you'll have the shape, the physical entity created. So now if we hit play, you see that it doesn't move upwards or downwards. So it stays exactly where it should be. So it's floating, as you can see. And you say, okay, but if it has neutral buoyancy, why it has this oscillation? Well, this is a physics stuff related. We don't have friction here, so it's one thing. So just a tiny movement, and as you can see here, these tiny movements could be generating this oscillation. Just because there's no friction, so we don't have implemented yet the friction with the fluid. Okay, maybe if you're interested, we could do a video about that. So, and that's it. So thank you very much for watching, and I hope these series of videos were useful for learning how to use buoyancy in gazebo or getting started with that. So thank you and see you soon. Bye.